Maybe. Let's talk after class. Well, yeah, we'll see. Let's talk after class just to be sure. I want to figure some things out. So, we are on lesson 4, and today we're going to be looking back at what you guys did on Friday with those Chromebooks. Remember that activity? And we kind of explored what effect adding or multiplying numbers had on the graph of a function. You guys remember that? So that's what we're going to be doing today. So by the end of today, I'm going to give you guys a function, and by the end of today, without a computer, you guys should be able to draw me a rough sketch of what it would look like if I were to do something to the function. Okay, that's the goal. Now we're going to spend 2 to 3 days, well, probably 2 days on this, 3 days kind of also, if you want to think of it as different. But we're going to spend about 3 days on that, and that's getting us close to the end of Unit 2. So, so first of all, what is a transformation? A transformation is some kind of a change that you make to a function that causes the position or the shape of the graph to change somehow. Okay? And that's what we did on Friday. You guys made a change to the equation, and that caused this shape to move or shrink or something, right? So that's a transformation. Now, there are 4 types of transformations. One is a translation. That's where you slide a graph to the left, to the right, or up and down. That's just where you're moving it. Kind of like this pen. If I just moved it from here to here, that's a translation.
Oh my God, wow.
I know, mind-blowing, right?
I'm sorry, I'm just so energetic today.
Drugs are bad. Drugs are bad. So, now, reflections. Reflections. That's like flipping it over an axis. That's like me taking this pin here and flipping it upside down. Right? Now, a reflection can happen vertically or it can happen horizontally, but there you have it. All right. Stretches. Stretches. Does anybody have some gum? Okay, so if you take it out of your mouth, you can stretch it, right? You can also smash it. Smashing is what we call compression. So you could do all those things to graphs. You could stretch them, compress them, you can translate them, you can reflect them, and that's what we'll be looking at. Yeah. Yeah. Where'd you learn that? Okay, very good. Now, each of these transformations can happen horizontally or vertically. Notice the picture of the line I drew for you, because a lot of us can't remember which is which there. So I drew a line that's horizontal, that's vertical. So you can translate things up and down or left and right. You can reflect things horizontally or vertically. You can stretch things horizontally or vertically, right? So all these transformations can happen horizontally or vertically. All right, now this is kind of like your main slide for the day. Or one of them anyway. Can you guys tell me, other than the fact that I'm using a different, well, let me, first of all, guys, translations, oops, sorry. Translations, remember, that's when you're sliding your graph around. You're not really changing its shape or size, you're just sliding it around. Translations happen when you add or subtract a number to your function somehow. So, when you add or subtract a number outside the parentheses, that shifts your graph up and down. But when you add or subtract a number on the inside to the x, that shifts it left and right. Okay? So, if you add a number, it goes up. So, adding is up. If you subtract a number on the outside of the parentheses, it goes down. Now on the inside of the parentheses, if you add a number, that actually moves it left, which to me as a math teacher is a little bit confusing, because positive, when you're going left and right, doesn't that usually mean right? But it's actually the opposite. So adding on the inside of the parentheses moves it left. Subtracting on the inside of the parentheses moves it right. How far does it move these things? It depends on the number. So if it's k, then you go up, like if it's, let's say k equals 5, then it goes up that high, 5 spaces. If it's, over here, If it's 3, then you go left 3 spaces. Okay? So that's what a translation is. All right? Let's go ahead and move on here then. So we're going to practice this now. All right. So on number 1 here, you guys have this on your notes. I've printed it for you. I printed that graph 4 times, and that way for each one you can write down the answer. So, Eric, I'm thinking it would probably be best if you went back to your seat and Paris got to be in hers, because I'm getting the impression it's going to be a little distracting. So why don't you guys plop there. Now, Paris, if you want to sit closer up front, though, you're welcome. Do we have one here or here? I think Eric wants to talk to his buds back there. Might not be so beneficial for his math education. All right, so here we go. F of x plus 2. Okay, so I'm adding 2 now. Is that 2 inside or outside the parentheses? And when it's outside, what did we say that do? Is that a shift up and down or left and right? Okay, so this is an up and down shift because outside now it's plus. So is that up or down? So I'm going to go up 2. So I'm going to take each of these dots here and I'm going to shift them all up 2 spaces. So up 2, up 2, up 2, and reconnect the dots. So I've shifted that whole graph up 2 spaces. Okay? What do you guys think I would do on the second one?
Down.
We're going to shift them down. How many spaces? Down 3 spaces. So we're going to go down 3, and down 3. So you guys have 2 separate graphs. I did mine on one graph, but if I were you, I'd put them in the separate graph that they belong to. So. And I'll turn this here for you. You can't see something if I stand in the front. You can also move. All right. So let's go ahead and do number 3 now. Now, what do you guys notice about that's different on number 3 compared to the first 2? It's in the parentheses. The number's in the parentheses, right? Now, what does that mean when it's in the parentheses? We're not shifting up and down anymore. Now we're moving left and right. So now when it's -1, which way are we moving?
Right.
We're moving to the right 1 space. All right, so in this case, we're going to move to the right 1 space. I'd like to be able to erase. There we go. Erase all the ink and bring back my marker. All right, now that's a highlighter. Please. Thank you. All right, so we're going to move every dot 1 space to the right. Here we go. 1 space here, 1 space here, 1 space here. Connect the dots. The whole graph gets shifted over 1 space.
Which one is the red one?
Yes, it is the red one. You guys are a little noisy, crunchy. All right. How about number 4? Is this left and right or up and down? Left and right because it's inside the parentheses, right? And since it's left or right, now we get to decide which it is. Since it's plus, is it left or right? It's left, and it's left how far? 4. None of this is true. I'm just making this stuff up.
Are you serious?
No, I'm
I was
just
like,
kidding.
why are we like?
Yeah. Is there a reason why the minus breaks?
There is, and it's a very confusing reason, but I'll show you if you're interested. I'm not going to talk about it to the class right now because it would probably not be helpful, but there is a reason. All right, so we're going to go to the left 4 spaces with every dot. Ready? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Connect your dots. That's it. All right. So, ready for some questions? I'm gonna randomly call on you. You've got to answer me correctly. If you don't,
Wait.
you'll be judged.
He's like,
He died.
All right, here we go.
I didn't know we were going that dark.
Kendall's not here today, so I can't judge Kendall, but let's do Leslie. Leslie. When a number is outside the parentheses, is that an up and down or a left and right? It is an up and down. It is an up and down. All right, let's ask another question. Annie. When you got a number inside, is that an up and down or a left and right? It's a left and right. It's a left and right. Now, how can you tell? Look at your notes. Look at this page I printed out for you guys. It's here. Vertical means up and down. Horizontal means left and right. All right. Let's do another one. Paris. When you add a number outside the parentheses, what direction do we go? Like, okay, so you have 4 options here. When you're adding a number outside the parentheses, is it up, down, left, or right? Which of those is it? To the right? It's a good guess, but I think it's. Let me bring back the slide here. Okay, which one of these has a plus outside the parentheses? Top left, top right, bottom left, or bottom right? Top left. Now what does it say? It goes up. So that's how you're going to use this chart. Okay? So if it's a plus on the outside, then you go here, right? Let's do another one. I'm going to ask you again, Paris. I'm sorry to torture you. This one has a minus on the inside of the parentheses. Which way do we go? Up, down, left, or right? That's right. Good job. All right, let's do another one. Micah. No, Michael. Michael. When we add a number on the inside of the parentheses, which way do we go? True. Kiara. When we subtract a number outside the parentheses, which way do we go? True. I'm feeling pretty good about this now. All right, so let's throw some at you guys. So, ready? Yours is printed on your paper as well. Go for it.
Do we move the whole B?
So what I did was I just picked 3 points off of my shape, and I just did the 3 points, but then I connected the dots, which is the whole shape. So yes, you're doing the whole shape, but I just use a couple points so that I can just kind of fudge the rest. So I would advise for you to use these points, Hannah. That one, and that one. And if you move those 3, then you can just connect them with a V and you're done. All right, ready? Here we go. Alicia. Alicia. Which way did you go for the first one? She went right too. So her answer would have looked like this. Oops. Your graph should look something like that on your first one. We should have went right 2 spaces for number 1. All right. Next. LaFontaine, which way did you go for number 2? She went down 1. So, down 1, down 1, down 1. Bye, guys. Oh. No. All right. So, that's what your graph should look like for number 2. Let's go ahead and take a look at number 3. John? Henry? All right. Hannah. Number 3, which way did you go? Uh-huh. Left, 1 is right. Well, I pulled your card, so that's the way it goes. It's a good thing we got to talk before I called John, huh? So that one would look something like that. All right, last one. Nelson, which way did you go for number 4? up 3, right? So for number 4, every dot should have went up 3 spaces. And it should have looked like that in the end. Okay? Continuing. Maybe. This is very odd. No. How do you get it off of the front? There we go. Okay, now we're going to do combinations. You guys ready? So we're going to do combinations of translations here. So in this case, I've got a +5 inside the parentheses. When you have a +5 inside, which way do you go? Left 5 spaces. And when you have a -4 on the outside, which way do you go? Down 4. So now we're going to do 2 moves. We're going to go left 5 and down 4. So for every point, we're going to go left 5 and down 4.
Oh, this is so easy.
We're going to, so I did this one, so I'm going to cross that off. Now I'm going to do the next one. Left 5, down 4. Thank you. Last one. Left 5, down 4.
Wait. Oh.
It's been shifted to the left 5, and it's been moved down 4. So that's a combo.
Wait, so this is it?
That's the answer. Yeah, we're good. Most of it. We have another, these are called translations where you slide them around. We're also going to talk about reflections today. All right, we'll see how those go. All right, let's go ahead and do another one. You guys didn't do this in Algebra 1, did you?
Yeah, I did.
How many of you guys did do this in Algebra 1? You guys had a pretty amazing Algebra 1 teacher. I don't remember that being a part of Algebra 1 standards. All right, here's one for you guys. So there's your shape. It's on your paper, printed once again. Do this combination. You're going to do 2 different transformations on this one, 2 different translations. Go for it. See if you can get the answer. All right, Adrian, what does this 2 indicate for me to do? Going to go right 2. Next, John Chavez, what does this -6 indicate to do? Down 6. So guys, for all 3 points up here, I mean, there's really a bunch more points than that, but I'm using those 3. I'm going to go right 2, down 6. So right 2, down 6. Oh, did I go left?
Yes.
Oops. Let me try again. Right 2, down 6. Right 2, down 6. Right 2, down 6. There we go. That's right. All right. Okay, guys. Let's continue. All right. So we're going to move on to a new topic now, new transformation. What we just talked about there was translations. So adding and subtracting numbers makes translations. But what we're going to do now is we're going to multiply our functions by negatives. Okay? If you multiply your function by a negative on the outside, it flips the graph upside down. It makes all the y values become negatives. If you have your negative on the inside, it's going to flip your graph horizontally. It makes all the x values change their sign instead of the y values. So let's go ahead and give this a shot.
No, and he hit me with this. The reverse card. And he but I saw one.
Oh my god.
Hmm. I don't really like this example very much, but I guess we're stuck with it. Okay. Let me back up a slide. I want you guys to add something to your notes. I want you guys to add something to your notes. Ready? So, vertical reflection, negative on the outside. It reflects the graph across the y-axis. In other words, it flips it upside down. Okay, now, that's one way to think about it. The other way to think about it is this is what I'd like you guys to do. It changes all y values signs. So when the negative is on the outside, it changes all the y value signs. So if the y values were positive, they become negative. If they were negative, they become positive.
Is that how it flips?
Yes,
Okay.
yes, exactly. Now over here, notice my negative is not in front of the f, but it's in front of the x. So that's going to change all the x signs. So for this side, we're going to say it changes all x value signs. It changes all the x value signs. So Micah gave me a suggestion. I think it's a really good one. So I'm going to go with that approach with you guys. And you could probably just try to eyeball it. Okay? Can I erase? Okay. So let me test you guys here. Can somebody come up here and, well, first of all, before I ask them to come up here, it's outside. So which way does it flip? Vertically. Can somebody come up here and draw what that would look like?
You want it? No, you want it? No,
He didn't do it on purpose. It's just, go ahead. Just do your best. It doesn't have to be perfect. Just what would that look like if you flipped it across the x-axis? Okay. Do you guys agree that looks like he flipped it over the x-axis upside down?
Yeah.
He did. Okay. That's right.
What? Yeah.
Now,
Okay, I did it.
but before you guys do it, I wanna show you guys another approach, okay? Because sometimes it's not quite that easy. So here's the other approach, is actually to label these points.
Oh, okay.
So on your guys' graph, the original one, would you guys label those points really quick? I'm gonna call on you to tell me what the numbers are for those points.
John, you shouldn't have that before.
Are you doing this? Did you do it? Do it. I'm gonna call people to tell me these points in a second. Maybe. Let me try Adrian Canizales. So Adrian, what's this point over here on the left?
1, 0.
1, 0. Now let me ask Eric Lloyd, what did you get for this point? Huh?
What did you even do?
Augustine, what did you get for this point?
5, 0.
5 0 is correct. All right, and then last point that we need, David, what's up here? 3, 4. Okay, now here's the other approach. Whenever the negative's on the outside, it changes all the values of which variable? The y variable. So we're going to change that to a -4. Where is 3 -4 at? You would go over 3 and down 4.
Mr. Bailey, you know what you can do is you can just exactly count down.
Yep,
Yeah.
that works too. Good.
Like,
3, 4.
like I have a, can I like draw an example of that real quick?
Let me finish this.
Okay.
All right, next one. We have 1, 0. Now 0 isn't positive or negative. It's nothing, right? So you can't change its sign. So guess what? it stays the same, which means it's right here. Same thing here. And so as you guys can see, it's the same answer that Nathan had. You just changed the signs of the y values. The only one that really changed was this one. The 4 became a -4, and so it's down here now. Okay? Huh? You can come show me something if you like. Sure, come on up. So you guys see that's a reflection? Okay. Now, let me show you guys another way. If you had trouble with that, I'm going to give you a more calculating kind of way to get it so that you don't have to guess like that. So, here we go. Let's get these points back up here. This is 1, 0, 5, 0, and what? 3, 4. Now, whenever the negative's on the inside, we wrote a note. What was the note? It changes all the x values. So 3, 4 is going to become what? -3, 4. And 1, 0 is going to become -1.
Do I get extra credit
0.
points for that? That was very
You went
frustrating.
up too high, so I'm afraid you I want my extra credit.
Thank you. And 5, 0 is going to become -5, 0. So you change all the x values, and that way you can kind of calculate it by just changing all the x values of the point. All right? That being said, you guys get to do 2. Now, let me help you guys out with number 3 before I cut you loose. On this one, you're going to do both. You're going to reflect it over the x-axis and the y-axis, but does it matter which one you do first? The answer is no, it doesn't matter. Now, another way you can think of this one is if you want to think of changing signs, then what signs are we changing here? X and y signs are changing. Okay? So however you want to do it, see if you guys can get those. Go for it. So number 1, when the negative's on the outside, we flip it upside down. Next one, number 2. Negatives on the inside. I'm going to have Raquel. Would you come draw where the line would go for number 2?
I got confidence, you know, I can't get on my seat.
Thank you. So that's correct as well. All right, last one. Vanessa Riggs. We have a negative inside and outside, so we're flipping it both ways. First we'll flip it upside down, and then next we'll flip it sideways. There you go. All right, guys.